We proposed a fast planning approach for 3D short trajectory with a parallel framework. In this work, we present a parallel algorithm architecture with the map planner and the point cloud planner for UAV's trajectory planning, achieving satisfactory performance in the planning success rate, path length, and fast responsibility. In this video, we will demonstrate the flight performance with a real drone in multiple environments, especially the reaction when faced with some intruding dynamic obstacles. The first environment is the indoor laboratory. The drone takes off from the start point and reaches the 3 goal points one by one. This is a totally static environment. The drone flies smoothly and the drone conducts both horizontal and vertical maneuvering to avoid the obstacles. The next test is conducted in the same environment, but a person will intrude in the flight field during the test to see how the drone will react. The goal point configuration is the same. We can see the drone fly to the left immediately once the person appears. The avoidance is successful and it reaches the goal at last. Here are the global map and the flight trajectory. The next environment is outdoor. It is very challenging because there is a slope. Also, the iron guardrail is too thin to be considered in the voxel map and the bushes are dense. Here the drone flies lower to avoid the bushes because there are fewer leaves in the lower space. In addition, we also conduct a test in the same environment at the night. The localization error is greater in a dark environment, but flight safety is not affected. The next test is performed in a grove. There are more than one people in this area to try to interfere with the drone during its flight. Besides, the importance of the point cloud planner is verified by the contrast test. It is shut down during the flight, and its reaction to the intruded person can be compared. First, we can see the drone can avoid a moving person agilely with PCP. After PCP is shut down, the drone reacts slower to the intruding person, and the flight may be unsafe. At last, we test the framework in a park with more people in the field interfering with the drone. Sometimes the drone has to take a violent maneuver to avoid a person very close to it. In conclusion, these hardware tests validate the practicality of our proposed framework in multiple environments. The drone can navigate itself to the goal and avoid all the obstacles agilely. Also, The point cloud planner is important to enable the drone to react quickly to those intruding dynamic obstacles. That's all. Thanks for your watching.